Hello guys, welcome to this video. It's the Ugandan Dev here, and in this video we are going to look at the history of concurrency. Concurrency originally originates from the guys in the railroad engineering, and that's why we are going to hear terms like semaphores, and we'll look at them in other subsequent videos. But concurrency originally is not a concept from computer science, but comes from the railroads and telegraphy. And yes, I've talked about semaphores, and we will look at semaphores later on in our course. Essentially, there's need to handle multiple trains on the same railroad, and that would be a big deal, that you want to have multiple trains on the same road. And all in all, you want these trains to arrive at their destinations safely. But we want to know, how does concurrency crosses from that field of engineering, railroad, to computing or computer science? And guess who brings it into computer science? The man we love, Dijkstra. And this was in his 1960s paper that he published in this field. And we know that concurrency, as with most areas in computer science, is still an incredibly young field compared to other fields like mathematics. Mathematics has been here since the dawn of time, since the creation of the world. So implementing concurrency in primitive language structures is quite hard. Yes, I bet we can all agree it is really hard. But the introduction of high-level concurrency primitives and better language support have improved the ways of engineers implement concurrent solutions. So with new languages, as we're going to see, they've given you some bit of high-level resources that can help you not to shoot yourself in the foot while implementing concurrency or concurrent programs, than implementing it in a primitive manner with primitive language structs. So language designers face substantial challenges when trying to implement concurrency, and that is not only safe but also efficient and easy to write. Yes, so guys like Ken Thompson, Kent Beck, guys like I'm forgetting his name, but the Go team, as we know it, that designed Golang, guys like that, Ken Thompson, when they talk about the challenges they faced while implementing Go, and to make it a language that can implement concurrency easily, you realize that it is really a big challenge to implement concurrency in languages, and that's when it comes to language designing. So languages such as Golang, Rust, Python have made great strides in this area. And for my viewers, please be reminded that on this channel we are going to be releasing videos in Golang, Rust, C++, and Python. So if you're interested in this, please leave a like, subscribe to the channel, and let's learn together. So there is this concept here. When it comes to concurrency, there are concepts that come out of concurrency as a way of implementing concurrency. And at a practical level, we want to look at the manifestations of concurrent programming. And these two things are threads and multithreading. But first, we want to look at a thread, and this is an ordered stream of instructions that can be scheduled to run as such by the operating system. And please mark the word ordered, because it carries a lot of importance for efficiency and the accuracy of the programs, to give us the expectations determinism. Threads typically live within processes and consists of a program counter, a stack, a set of registers, and identifier. Those 4 characters of a thread are important: counter, a stack, a set of registers, and an identification. So, but it's also important to note that threads live within processes; they don't live alone. Not like you. These threads are the smallest unit of execution to which a processor can allocate time. So your processor is going to allocate time or time slots to the programs or the instructions that it is receiving and schedule them for execution. So the smallest unit that a processor can allocate time will be a thread. So we want to look at how do threads behave while in programs, and we want to talk about communication in this sense. And in other words, the communication of threads. Threads are able to interact with the shared resources. They can interact with memory and storage depending on what we've written, and with this behavior comes some problems. So you need to have responsibility when you're writing your threads because of this, as you're going to see. So they can also communicate within themselves, inter-thread communication or thread to thread. And threads are also able to share memory, read, write different memory addresses. And this can result into problems if you're not careful. If threads, 2 threads sharing memory and the order of execution is not guaranteed, the program might crash or give wrong values, because if these threads, the order of execution is not guaranteed, they could access that given value at the same time. Imagine they are accessing a bank balance and these 2 threads are running concurrently and they are withdrawing they are withdrawing maybe the same amount, and because it is happening at the same time, there is a likelihood the program can behave in a way that we can't predict at this state. We can assume that the program can give the customer money more than what he has at the account, more than the balance. So you need to be careful when you're writing threads, and we can't run away from them. So with that, I'll leave you guys. Please leave a like, comment, and subscribe to the channel if you have enjoyed this video. Leave a comment. If you don't like it, leave a comment and say what you don't like. Let's have the conversation in the comment section. Bye bye.